So next one which are going to solve is very important. So notice it carefully and learn how can we are going to solve this problem. So just see, that is the fifth part of some standard form, that is integral e raised to power ax into sine bx plus k dx, k may be 0 sometimes, is equal to e raised to power ax over a square plus b square in the bracket a sine bx plus k minus b cos bx plus k plus c, where a and b is not equal to 0. So we have to form this result. If you see, you have to learn like this: e raised to power ax under root divided by a square plus b square into a into sine of this minus b into cos of this. That is a derivative. If you see, sine derivative integration is minus cos. So just remember this. And we have a and b there, which is a function that will come out with a, and sine is come as minus because this is the integration of sine. Simple sine, not using the proper integration rule. This is way to remember this result so that we can use in the problems directly. So we are going to prove this result. Just see, let I is equal to integration of e raised to power ax into sine of bx plus k dx. So taking sine as first function and e raised to power ax as second function by, if you see, it is by ligate rule. So I is equal to sine of bx plus k into integration of e raised to power ax, that is e raised to power ax over derivative of ax is a, minus integration of derivative of sine bx plus k. Derivative of sine bx plus k is cos of bx plus k, and into derivative of this bracket, that is b, into integration of e raised to power ax is e raised to power ax over a whole integration dx. So while doing this step, do very carefully. A little bit mistake make the question wrong. So we get e raised to power ax over a into sine of bx plus k minus b over a taken as common, and in the bracket, in the integration sign, we have cos of bx plus k into e raised to power ax dx. So here we have to again do the rule of integration by parts. So I is equal to e raised to power ax over a into sine of bx plus k minus b over a in the bracket cos of bx plus k as a first function, and integration of e raised to power ax is e raised to power ax over a minus integration of derivative of cos bx is minus sine bx plus k into b into integration of e raised to power ax is e raised to power ax over a bracket close dx whole integration and whole bracket close. Do this step very carefully. So I is equal to e raised to power ax over a into sine of bx plus k minus b over a square e raised to power ax into cos of bx plus k. Minus minus plus, again minus, it becomes minus b over a into b into a, that is minus b square over a square. Integration of e raised to power ax into sine of bx plus k dx. All integration. So if we see, we get again I here. So while introducing I, we have to add constant of integration. So we get e raised to power ax over a sine bx plus k minus b over a square e raised to power ax into cos of bx plus k minus b square over a square I. So from here we get 1 plus b square over a square outside I is equal to e raised to power ax over a sine of bx plus k minus b over a square e raised to power ax cos of bx plus k plus c, that is the constant of integration. So we get I into a square plus b square over a square, which is equal to e raised to power ax over a sine bx plus k minus b over a square e raised to power ax cos of bx plus k plus c. So from here we get a square over a square plus b square into e raised to power ax over a sine of bx plus k minus b over a square e raised to power ax into cos of bx plus k plus c. So we get I is equal to a e raised to power ax common, a square plus b square is also common. We get a square over a, that is a sine bx plus k, and a square cancel out, minus b cos bx plus k bracket close plus a square c over a square plus b square. So we replace this whole quantity by c dash, that is the constant of integration. So we get I is equal to e raised to power ax over a square plus b square, that is a sine bx plus k minus b cos of bx plus k plus c dash, or we can say c is the arbitrary constant. So we get I is equal to this. Now we can change also the form of I by, this is the one form, and another form of I is we can write this as under root a square plus b square, and this one part is going inside the bracket, that is a over under root a square plus b square sine of bx plus k minus b over under root a square plus b square cos of bx plus k plus c dash, or we can say c. So here if we see, I is equal to e raised to power ax over under root a square plus b square by introducing this as cos alpha. So we get sin bx plus k into cos alpha minus this as sin alpha into cos of bx plus k plus c dash, where cos alpha is equal to a over under root a square plus b square and sin alpha is equal to b over under root a square plus b square. Then tan alpha is equal to sin alpha over cos alpha, that is b over a. That is alpha is equal to tan inverse b over a. Therefore, I becomes e raised to power ax over under root a square plus b square sin a cos b, if we see, minus cos a sin b. So it becomes sin a minus b, that is sin a minus b, where alpha is plus c dash, where alpha is tan inverse b over a. So this is another form to find the integral of e raised to power x, e raised to power ax sin of bx plus k. On the basis of this, we are going to do one exam. Now we have to find out integration of e raised to power 2x sin of 3x dx. So here we can use this formula. Let I is equal to e raised to power 2x sin of 3x dx. So if we see here, a is equal to 3 and b is equal to, a is equal to 2 and b is equal to 3 and k is 0. So by using the above formula, we can get I is equal to e raised to power 2x over under root a square plus b square sin of bx minus alpha plus c, where alpha is tan inverse b over a, that is alpha is tan inverse c over 2. Therefore, I is equal to e raised to power 2x over under root 2 square is 4 plus 3 square is 9, that is under root 13 sin of bx, that is 3x. 3x minus tan inverse 3 over 2 plus c. This is the one exam result, and another result is, or I is equal to e raised to power 2x over a square plus x square, that is a sin bx plus k minus b cos bx plus k plus c. So this is another form of this result. You can use any result. So according to option given in the question, you have to familiar with these two results to get your required result. So this is all about the formula e raised to power ax sin bx integral of this integrand. So this is not complicated, this is a lengthy and time taking. And we have to do this step by step very carefully to avoid mistake.